Hi, I'm Jim Huysentruyt, and welcome to our podcast series sponsored by PcVue SCADA Solutions. Let's Engineer. Today, I'd like to welcome CEO of Chia and Simulation Dynamics Incorporated, Andy Siprelle. Welcome, Andy. How are you doing today?
I'm doing great. How are you doing, Jim?
I'm doing real well. I have some questions here. We'll get started, but really, the first thing I'd like to do is go ahead and tell us a little bit about Chia and simulations dynamics and kind of what you do there and a little bit about your journey.
Sure. Yeah, so I am CEO, founder of both Simulation Dynamics, which I founded some 30 plus years ago, 32 years ago. In uh, Virginia, born and raised, well, not born. I'm actually born in Tennessee here, where I still live today. But in Virginia raised, dangerously close to the swamp, and I went to two Virginia schools, two Virginia universities, University of Virginia first, and then Virginia Tech. It was Virginia Tech where I fell in love with simulation, and I got a degree in industrial engineering and operations research, or IEOR. But yeah, Virginia, dangerously close to the swamp, big family, big Catholic family, fifth of five kids, 30 cousins, and we all share a property out in Montana. I'm near relation to the brothers featured in that show that Fox Business made during COVID called American Gold, The Legend of Bear Gulch. So yeah. So I
Okay.
actually transferred to Virginia Tech originally to be a mining engineer, and I had family. Then I got down there, and my Uncle Dick said, there's no, there's it's really a bad choice. You know, you got to go somewhere foreign to make money kidnapped. And so I discovered industrial engineering and fell in love with it. And you might say that I'm a hardcore IEOR junkie, as it were. And I'm a bit of a coding junkie as well. I sort of got into that early. And so simulation dynamics, if you will, is 30 plus years later, to sort of paraphrase Tom Waits, living proof you can make a career out of a college course.
There you go. And really, when you think of operations research, and maybe we could give a little bit of background, especially back then, what operations research, because there's a lot of, I guess, kind of taking your linear algebra and moving it, right, and putting constraints.
Sure.
It's like the quantitative analysis, right? That's, as far as that goes. And, really, how did you apply that, to the real world?
Well, that was the thing. While I was always, growing up in Northern Virginia, but then being exposed to the real world in Montana and doing mining with my great uncles out there, in junior high or in high school, I remember I spent a summer with them, and they had me on a ledge, with a rock drill, and I was covered in rock dust, and they had retired, and they sort of bought up this canyon, and they were prospecting for gold. And so, growing up in Northern Virginia was very sort of unreal. My dad worked for the Bureau of Engraving and Printing. He was a mechanical engineer for them, printing money, you know, and things didn't really seem quite real, in the Northern Virginia swamp. And so I yearned for real. I got offered a job working for Anderson, and I said, no way, no way. You can throw me into that, and I'd love it, doing all that, stuff, computer type stuff. But I really wanted to see manufacturing. And so I took a job with Alcoa, all because they were talking about simulation and modeling and how they used it for capacity analysis. Alcoa always did a good job, going way back to the 30s. Well, even before that, they were, if you remember your American history, they were part of like the early antitrust cases because they were too good at predicting when to add capacity.
Mhm.
And
Yeah,
so I
so,
did I did capacity analysis for them, and they even studied, their customers. So we
how were
modeled
you collecting the
them
data
too.
back then? Were you collecting it manually?
Oh yeah. Oh yeah. Yeah. Back way back before big data, And so when I first joined Alcoa, that was the beginning of the personal computer revolution. They didn't even have PCs in plants. And I was using the very first ones there, and they were doing hardcore simulation models of their plants.
Okay.
And we had gigantic, spreadsheet models that we did as well
Okay.
back in the day.
Probably using Lotus or something back then, right?
Excel on the Mac, actually, the
Okay, there
very
you go.
first version
Okay.
of Excel was way more capable on the Mac.
I
Yeah.
remember that.
So, yeah.
So now you're getting this data. As far as the technology, maybe you could talk a little bit on how that technology evolved on just collecting the data and doing the computational analysis.
It's very interesting. As I said, I was a computer. I got hooked on computers in school, taking a Pascal course at University of Virginia first. And then as we talked, I got into Turbo Pascal and later into Delphi and whatnot. But really, what got me hooked was this general purpose computer simulation, general purpose discrete event simulation package that I discovered by reading an article at Byte magazine sometime in 89 or something. Getting into that, you know, it was just that became the basis of a whole. We trained people in computer simulation in building how to build models of their lines and multi-stage plants and then later entire supply chains. And grappling with data was always a problem. Companies that were pragmatic about this, it was almost hard to believe in the early days how hard it was to do this, because as far as the data goes, oftentimes people would go through a massive static data collection, build this enormous model, and then throw it away, after a one-time study,
Oh,
you
gee.
know,
And so it's
you know,
gone because they're just doing it in
gone.
spreadsheets. So it's like, I don't
Yeah.
need this anymore.
Yeah,
Okay.
right. So, we saw a lot of that. We worked with this general purpose package, doing some very audacious models. We built libraries on top of this general purpose package in a subset of C called Model. And so we built our own libraries and used this mainly in the consumer products space, food and beverages, some mining, but also for the DOE and the military and all kinds of folks. A turning point for us really in our whole journey was we were dealing with lots and lots of data all the time, and like I said, trying to turn this into a company asset was hard because for numerous challenges to this, people would show up at our training having received a model, been beneficiaries of a model, but they were showing up at the training just because they couldn't understand how to drive the car without knowing how to be car mechanics.
Well, yeah.
Yeah,
And I think that was part of, especially back in the dawn of
yeah,
when simulations being actually used. Because where is all this data? Is it
yeah,
in
yeah.
spreadsheets? Is it in databases? So you got to know how to extract it.
Yeah, and the data was getting ever bigger and bigger. So sometime about 20 years ago, we just were doing projects that were just too big for this package, and so we burst out of the seams of it, and we ported some of our supply chain simulation libraries into .NET, and so the first big job we did and this was really the turning point because this was the beginning of what I'd call model-based apps. And so this was a job for a joint venture of Chrysler and Union Pacific Railroad. And it was actually a transportation logistics job. And they had this massive system called VinVision. So they managed the distribution of brand new vehicles, Chryslers from fab plants out to dealers via rail, barge, Mad Max, retired couple truck trailer out of ramps. And so we built an entire model. But a key to this was it was really important. It was it was a good use of the technology because this VinVision system they had already built was this real-time visibility system. You could type in a VIN, a vehicle identification number, and it would tell you where it was. And so what they asked us to do was to build this model in such a way that we could suck in the state of where it was at time equals zero, suck in all the status of these vehicles, upwards of 150,000 vehicles to represent
Hmm.
now. And then from now into the future, pump out continuous vehicles from fab plants based on schedules.
Okay.
And so we
Okay.
could give, loading ramps and unloading ramps, heads ups on what labor they would need. We could help them during, they used it, to figure out how long it took to equilibrate the network during hurricanes. The CFO even used it to do the budget annually. So
Right.
so this was a turning point because we could leverage the big data very importantly, very effectively with .NET. But most importantly, we could provide a UI that allowed a business analyst to steer it. And that was big. That was a totally different thing. That was not an IE. And so they used
Right.
that
Right.
model for a decade and it led to enormous savings.
Well, I can imagine. I can imagine taking it and to anything from food processing, chemical processing. You could take that same model. So and having a UI where a business guy can do it. And I'm not saying I mean I was just saying you don't have to be a computer guy anymore,
Right.
right?
You
And
don't have to be an
that's
IE, and that's who
right.
they had running it
And that's
before.
yeah. So with this model, because I know you've worked in with chemical and other type of plants process and applying that to process, because now you're collecting data in different ways, right? You're getting
Yeah,
data, it's where you're getting your throughputs, you're getting real data, but whether you're doing it on packaging or you're doing it on, or maybe from the batch on down, I don't know, or from what you need to put into the batch, right? And
right, right.
as far as the data now, because now we're talking about this data, and how do you, when you go in to a system, you're saying, okay, they're saying, oh, we love your simulation model, we want to do all this stuff. Obviously, the benefits are huge, right? I mean,
Yeah,
if you could just get the throughput up by 5%, by that much, that's millions and millions of dollars.
yes,
But you're sitting in a situation where they have old legacy systems, and then they have newer systems, and then they have whatever their ERP system is. How do you put it
it's
in a format that you could read?
well, everybody's different, and everybody starts at a different point on this, right? It just so happens that who we've worked with, has been what we would say suitable conditions for life to work in this space. Not everyone has the information architecture to pull up valid data from every manufacturing line all over the world, right? But some do. And I can speak to the issue, of data readiness. It's been all over the map who we've worked with. When we went back in the old days, when we went into plants, they didn't have line event data systems. And what this is and they still don't.
Okay,
Yeah.
actually, I want to take a
Yeah.
step back
Yeah, yeah,
and
yeah,
maybe
yeah.
explain what is a line event data
Yeah,
system.
what is a line event data system? Well, so first of all, let me answer your question by answering old school. This is the consulting practice. Say we're building a model of a breakfast cereal. We're trying to understand the throughput and the availability, the capacity of the entire line. We would actually, step through every piece of the production process and ask the question, what slows it down? What constrains it? And in addition to that, things like, what makes it stop, most importantly, Because as an old boss of mine said, Andy, from Alcoa, it's not the little fine tuning of things that is really, causing manufacturing facilities to go out of whack, like fine, control. It's really the big crash bang booms. It's like the things that we do on a casual basis, shut down the 049 slitter in the north plant, and
Mhm.
move it to the west plant or
Right.
vice versa.
Yeah.
So it's the
But
crash
you also
bang
have,
booms, right?
I mean, because when you have a line stop event, you have really changeovers. You
Yes.
have little
Yes.
things like if you're
Yes.
replacing film on or what have you,
That's right.
and
Yes.
there's a lot of them, and getting those is
Yep.
that's
Yes,
an art.
exactly. And so this is a critical source of us, I'll call it raw material for prediction, if done right, a line event data system. So with a line event data system, we want to record through sensor or through a combination of sensor and operator every reason that the line goes down. We want to know what it's for, no matter what, if it's a failure mode or it's a planned stop. And if we have that data, we can make a lot of really, really good prediction. In fact, we can make predictions. Simulation is like the analytics of the future. We can, if we have data on stops, and it's configured well, we're tracking the right things, um, then we can not only validate systems of the baseline that exists today, and figure out what improvements to make on that system, but we can also do analytics on systems that haven't even been built yet, but still using that equipment. You know what I mean?
Right.
Just in different arrangements, serial, parallel, etc. Yeah.
So okay, interesting. So or you could try to predict the change because you're gonna introduce a change, right? But you have
Yes.
all the stuff that's all the basically data of of incoming and outgoing, right? As far as how
The
fast
high
you can go.
That's right. The high fidelity behavior of um, the internal stops on a line is critical because it's the external stops, the blocking and starving, and the
Hmm.
possibility of that we actually simulate.
Hmm.
We can take the data and create very, very high fidelity simulations. Now, some folks don't have the data, and certainly data readiness is one of the big challenges. And I can speak to that some more. We could talk about that all day long. But I think that a lot of customers in this space that we address know that 90% OEE is possible, operational efficiency and effectiveness. They just don't know
Right.
how to get there. And really, it's quite amazing that in modeling, there's been a lot of emphasis on the physical models, computational fluid dynamics and finite element design for packaging, all of those things that they get a lot of attention and the manufacturers court that kind of modeling because they know they need it.
Hmm.
But what I see is that, I talk to people, even at big companies where, I talked to a guy who works at a big pharmaceutical plant, and he said, our plant still operates like it does in the 80s, So they're generally in this space operating in the 60s or lower. They know 90 is
And
possible. They
right.
just don't know how to get there.
Right. Well, I mean, from the OE side is I find going in and you're talking OE and really they have a baseline where they're at. Really, there's so many in the 30s and the 40s in I mean, just in that range, and which is so working with OE, it's kind of nice being the first to come in because we can get some victories fast, and we can get
Yep. Yep.
that first 10 we can usually get pretty fast. But
Yep.
it's when you're fine tuned, when you're getting to the next level where you can get to like you can get to 70, 75, 80. That's world class what I see in most cases.
Indeed.
So
Yep.
yeah. Yeah.
But what we see is that, when it comes to answering the strategic questions, for supply chain throughput and reliability. That's not really happening much at all. That's a big challenge for manufacturers. The companies selling equipment, they often use simulation models just as part of a selling exercise.
Yeah, yeah, yeah. And a lot of times they'll put OE rates on them that aren't achievable, but that's another story
That's right.
because it's
Well,
a
that's
perfect
part of the
situation,
story.
right?
Yeah, a lot of times their motivation is to sell equipment. And so, they'll quote you repair times, that are just based on their technicians' repair time. Like
Right, right, yeah, right. And
they'll
and they're because they're doing it all the time. That's the
right.
thing, right? So that's
They'll
yeah.
quote you 20 seconds when in reality in the plant it takes 2 or 3 minutes because your operator's not standing there with a toolbox all day like their technician. So that'll make a huge difference.
Okay. So tell us a little more about some of the tricks that you've come up because I know you have some things, especially with Chia, that you're doing some things with discrete rate simulation, and you're basically have
Discrete
a
rate.
model of competing risk. Maybe you could tell us more about some of that.
It struck me about a year ago after 30 years of simulation dynamics being like an incubator for ideas. We ended up doing stewarding a matrix of innovation projects, I guess you'd say, and stewarding them from, I'll say, zany idea or some grad student's project, in Python or whatever, all the way up through potentially enterprise apps scaled on a worldwide scale. And then edge apps, something we planned as well. So I wanted to, a year ago, because of what we just discussed as the challenges and also the opportunities, you see all of this IoT and IIoT, and you see the possibility of cheap, sensors being used and all of the opportunities these days that manufacturers have. And I thought, that this little trick I invented, as you call it, some 30 years ago called discrete rate really could play and help people in this field. So about 15 years ago, the trick you're alluding to is a first of all, a term of art of my coinage called discrete rate simulation, and it's a variant of discrete event simulation. That's something that we all industrial engineers learned in school. Some 15 years ago, 20 years ago, I developed a library on top of a general purpose package, and then I marketed it commercially as well in a joint venture with the vendor. And at the heart of it, it's about representing production processes using rates as alternatives to items.
Okay.
And it's very applicable to CPG and food and beverage processes. We even went to the 1 year, 2 years, we went to the Powder and Bulk Solids Show conference. So now that's an exciting title for you. But the thing about discrete rate that was new is that it's ridiculously easy to understand as a worldview. Lots of folks think in terms of rates, anyhow. Electrical engineers, chemical engineers. It's only us, we weirdo, industrial engineers who talk in terms of items. So it's ridiculously easy to model in, and it has it's easy to teach folks. We've tried to teach folks discrete event simulations systems. I taught hundreds of classes back in the day, and our success rate for this stuff was very, very small. So we know, but another property about discrete rate is that, like discrete event, and we're talking about models that run in compressed time, not real time. Okay. Because we need to run them in compressed time to make strategic decisions, right? So one of the properties of discrete event is that it compresses time so that the models run faster, hopefully, than real
Okay.
time, right?
Okay.
And discrete rate does this even more drastically. So it results in really models that run so fast that you can do what I call practical, true stochastic problem solving, and even
Okay.
develop an intuition for how to improve the system through running simulations.
And so Tell us a little bit about what the data needs to be. I mean, because you're probably talking about a lot of data that you're reading fast. Do you
Right.
take that data and put it into a different database or?
Sometimes databases and table structures are important, but and most importantly, yes. I mean, what a big part of what this innovation is that it's what I call a composable simulator, not a simulation, a general purpose language. And so we can develop some very effective models that are what I call model light, data heavy. we we're used to working with people and teaching them general purpose simulation only to see them building these Picasso style things that, they're obviously trying to get to the moon, by way of climbing one branch at a time. And so part of this innovation I've come up with is nodes that you use to model in that have a very rich construct underneath machines or anything that's likely to stop. And this construct is using a model of competing risk that was developed for this industry from back at 20 years ago in the national lab. And so what we're looking for, to model, first of all, is rates, right? We want to know what the max rate of machines are. That's important.
Okay.
And then we want to
Okay.
know when they stop. And that involves interrupts, which we discussed, right? So when you're driving your car and you get a flat tire, these are discernible and actionable tuples of time to failure, time to repair.
Hmm.
And so, we need to somehow take the data on all the stops from something, hopefully, like a line event data system.
Hmm.
And we need to coalesce all of those stops into interrupts. And these interrupts essentially have a time to failure, a time to repair, a clock type. They run according to certain clocks, either the wall clock or runtime. And then they have a group cause name. That's how they coalesce. So if you get a flat tire and you fix it with one of those fix-a-flat things versus you fix it with, having to change the tire or say you got no spare.
Yeah.
Those are
Yeah. Okay.
three different,
Right. Right.
interrupts.
Right.
And they are distinctly different interrupts because of their repair mode. Now on the actual event, if in their recording there's some operator or manual entry, they can say anything like, change tire or used spare, right?
Right.
And so our job is to clean and
Normalize the
map
data to
those
where,
into
yeah, normalize the
coherent,
data.
actionable
Okay.
interrupts.
Right. Okay. Okay. And really, with everything you're talking about now, and yeah, how are you using AI? Are you using AI yet? I mean, with everything
AI
that's going on
is
in that world.
AI is really interesting because of course, digital twin plays heavily in AI, and people are,
Actually,
I think
I'm gonna take a step back. You mentioned digital twin. I want you to define digital twin for our audience because I think there's different
digital
views of
twin.
what digital twin really is.
Yeah, yeah. Yeah, there are a lot of folks using that term these days. We were working with a fellow who just developed a real-time dashboard on Power BI, and he said, "Look at my digital twin," you know. And of course, I think it's a great term. Okay, I'll say that. And I think that the term has had a good effect because it's really rejuvenated and put a spotlight on my field, simulation. But in addition, the term emphasizes a focus on the decisions instead of the method. And a customer of ours developed a saying, I'm not sure where he got it, but we quote it sort of mantra-like, it's the decisions, it's a digital twin. The definition is this. It's about decisions, past, present, and future automated.
There you go.
But, in my world, I see a lot of folks equating this with 3D animated movie looking simulations. That's what it's about. It's an overemphasis on the geographical or geometric or kinematic or physical details of the process. To really leverage, I think, a digital twin for your problem, it's got to not only look like it, your process. It can't be skin deep, right? It's got to behave like your process. If I think the connotation, the idea connotes or brings up in our mind, like, if we had a twin, what would we do with it, right? And so in my mind, it's really got to behave like your system and on a level that's useful in a kind of a George Box way in honor of him. All models are wrong. They're only useful. And so I think I've spent 30 plus years of my career really trying to not only make models more right, but most of all, more useful. And so what people really struggle with still to this day is these questions that we answer. We answer strategic questions about your production line. How many how many of stretch wrappers do you need? What speeds and reliabilities of the components do you need? How much? How many? What are the relative rates of these different machines? How many buffers do you need and how big should they be? Should you run some parts of the line faster than others? And it's all in the context of Goldratt, and theory of constraints and lean production and Toyota. It's a dumb idea to have idle assets, right? Is what they say, but it's the context of it, and how it's used in the line. So we have
So
our own software that does that and helps people to do that, to figure out those
right,
questions.
and at the end of the day,
Predict
you're
availability.
right,
Oh,
and
sorry.
be able to. Sorry, and I jumped on you a little bit, but at the end of the day, it really is. I mean, your success is you know increasing throughput, right?
Yes.
And that
Yes.
is at the end of the day is if you can increase that rate, that's right, and you can
Yes.
increase that rate on a consistent basis, right? Or to put it in terms of OE, you can get that OE rate up to where it is now and pop it up there. The guys in the suits are happy, right? Because that's
That's right.
really
That's all they care about.
there's the one, and they're the ones we have to make happy at the end of the day, and from the skater world. Our job is to get data in a format. I mean, amongst other things, but one of our big jobs now is getting data, bringing it in, doing whatever massaging we could do, pre massaging we could do, and putting it into a format to
Yep.
where you could use it. And of
That's
course, we're
right.
not it. We're not it, right? Because there's a lot of different places that you're getting your data, and of all these different technologies now. And really, one of the questions I have for you now, because I'm looking at this evolution of what you've done from back in the day, right? Back when you're in school and then just getting out of school. So to now, right? And you
Yep.
have, it seems like the
An
software's getting better,
avalanche of data. An
right?
avalanche of data. Yeah.
But also with the technology, it's being able to present it to, and I'm just going to call it the more average businessman, right? The guy on the guy doing the financials, the guy ordering, right? The guy doing the ordering could get data from that. As far as it
Right.
goes, it goes to a bunch of different areas. And really, as far as it goes, look at how would you predict the field in 5, 10 years with this technology? Where do you see it?
I think, gosh, well, see, I've been like I mentioned before, I've been very lucky to work in a space where there's been a real emphasis placed on architecture for information, and
Right.
data readiness. Almost all of what we do, as I mentioned, involves eventually building a mature model-based app. And so the company the ecosystem in which I've worked primarily has built fantastic SCADA systems for collecting this data right off the line. And Well, we've worked in, and you mentioned SCADA, and we've worked in all three layers except maybe control, I'd say.
Okay.
But we've been involved in wiring up lines and stuff like that. Interestingly, those models are real time versus compressed time, which is where we started. Even the same, even in these huge organizations that have built out this information architecture to do this stuff, it's been incredibly difficult to build a pipeline of innovation, which is what we really do. In our ecosystem, we serve as an incubating service for zany ideas, and we also serve as an enterprise and edge level DevOps organization for mature smart apps. So we manage a matrix of these ideas along a product lifecycle, and they always start with the consideration of models. And for models, models have to work. And assessing the data readiness, with often the goal to steward them into a production, edge, or enterprise app involves a ton of time validating them. And we had, when this big data thing came on, we actually had a model ready for all this that was, that big data was going to feed. And we had an analytics person validating the data for 4 to 5 years.
Wow.
Yeah.
Okay.
And so I predict a lot of churn for the next 5. See, I think that the ecosystem I've been working in is about 30 years ahead of the industry, of the rest of the CPG and foods and beverage firms. And so, chat can certainly help, because analysts spend about 80% of their time in this space cleaning and collecting and all that. And so, yeah, that's some of what I had to say about that. I mean, there's certainly a ton of things that manufacturers can leverage around cloud computing and high performance computing. There's lots of techniques from practical AI that we can use and are using to do the data cleaning thing around what I was just talking about. But you have very useful things like decision trees and Monte Carlo tree search and neural nets. And I think there will be a recognition more and more of what higher level things can be answered through more robust and more advanced models. And I think it'll become more and more evident to the person on the shop floor. I think in some ways, chat offers the possibility to radicalize the user interface for these models. Given that, and so I think too that a cultural shift is coming and has to come because of what's required for innovation. I run a 7-ring circus in my business, and my teams work on totally different planes.
Hmm.
And the things that we do require some real risk taking. So that's going to have to become accepted and nurtured within organizations.
But I mean, you do essentially mitigate the risk in a sense, right? I mean, can
Sure.
can you kind of front load the risk a little bit so you don't, because obviously 4 or 5 years is a long time, right? It's a long time,
That's a long time.
and
That's a lot of churn,
yeah,
5 years of churn.
yeah, yeah, and that's just one of those. I mean, to get a CO and get the get the you know that C group to buy into that, because
Right,
that's not an easy thing to do because it's money, right? And then
right.
a lot of times if they're looking 2 3 years out, that's a long time for, I'm gonna say, especially the medium, because the bigger companies, they have they have departments that are thinking that, right? And then they go that while they continue to do their business. But how do we take what you're doing, right, and get it to the medium-sized company or the small companies, as far as
That's what we're trying to do. We're trying to show them what they can do with just a little bit of data. You know,
right.
What's ridiculous is that even the simplest of questions, that are possible to address using simulation are not accessible to those sized companies. And I just think that's That's ridiculous, and that needs to change. I mean, even if you, I mean, we found in one instance, you don't need to start with a ton of data. I mean, for instance, you do need to know simple things like, if you're making French toast sticks, how many sticks go in a box? And, for this SKU, how many boxes go in a case? And, how many cases go into a pallet?
Hmm.
That kind of data on physics and is very important to understanding. Those are production physics we need to know and are accessible, right? It gets harder when they try to quote their reliability. Back in the day, we simulationists would go into a plant and we'd say stuff like, well, how often does it stop? And what's your percentage uptime, and also when you repair it, give us a triangular distribution for it, a
Yeah,
minimum, a
right.
mode, and a max.
Right.
Nowadays people have the possibility of a lot better information.
Yeah, and there are systems out there like for OEE, there are
Yes,
systems out there where you can put something in there and you can get that data and because that's part of the culture. I think a
that's
big
right.
part of it is like you talked about the whole culture for the whole big piece, but really just on the plant floor, getting them to collect data, know your OEE, and when you know your OEE, not just your stoppage, know your rates. Why is it running slow, right? Versus what because you'll watch OEE sometimes the rates will do this
Right.
throughout the day,
Yeah.
and
Yeah,
and it's not a stoppage, right? And and knowing why it's doing that, right?
that's
Getting
right.
that information.
I mean, it's really an interesting thing, this whole thing about relative rates. I taught engineers simulation for many years, and a big part of my teaching, I began to use this kind of sound effects of like slurping, and I'd say, okay, when you're packing Folgers in big red can, the packaging line has a higher slurp rate, because it's still pounding
Sure.
out at the
It's true.
same, cycle. But now, that's causing relative rates, in the buffer to be sucked down faster. And so therefore, we're going to empty bins faster. It's really important to people to show people these dynamics. Throughout the 2000s, we also got involved in multi-stage packaging, multi-stage scheduling problems. And those are some of the most difficult problems to solve in the world. In a pet food plant, for instance, because of this relative rates thing and the scheduling and the amount of bins that are in place, it's very much like a game of free cell. Have you ever played free cell? That card game where you can cheat. You've got four places you can kind of lay down cards, and it's like
Okay.
solitaire, but you can cheat. And you have these four like buffers in essence, and those buffers are more or less like analogous to interprocess buffer storage
Mhm.
availability in a
Right.
manufacturing line. And so this pet food plant, everybody knows that, in free cell, to get better at it and win, you've got to really be judicious about that space. You can't give it up easily, right? Because when you do, and you give up all those free cells and you get stuck, you're done, right? And so the same thing happened in this pet food plant. And they get all their bins loaded with all the wrong product in the day. And throughout the day, anytime throughout the day, they get it loaded up, and then it's bin lock is where all of the stuff that's sitting in bins
The wrong
can't
stuff.
progress downstream
Right.
because the schedule's not ready to take it. And so this was a condition that, they get 3 or 4 times a day. They call up the scheduler in the middle of the night or whatever. And this is a problem I think that is largely unsolved still. And I just wonder in how many places this exists.
Yeah.
And I think
It
it's
is interesting
everywhere.
because and I see it all over the place, definitely. But I think some schedulers are better, but it depends, because I
Sure.
think
It's an art.
companies that tend to run leaner and get the stuff out faster. But then you have dedicated lines, and if you have a lot of changeover, but we can keep going there. I think we do need to kind of wrap this up here because
And there's
we're
and there's certain designs actually have an inherent maximum availability as
right.
well.
Yep.
That's something to think about as well. A lot of manufacturers design their systems for maximum flexibility, and then that requires them to run a maximum schedule,
Right.
and so yeah,
Well, Andy,
challenges.
this has been really good. Okay, we can go on forever. I could I mean
Yeah,
I
yeah,
could go on forever, but we need to we need to wrap it up just because of time.
we
But
probably do.
I do want to thank you so much for just coming on and just talking about simulations. It's a it's a whole different way of thinking. It really is, and but just looking at a lot of our customers and mutual customers. I mean, the ones who are doing it, I think the ones that see the success and once they see the light, I think they'll keep doing it. It's the ones I think there's a lot that aren't doing it right now, and it's just really what would be your biggest advice to somebody? I mean, it's say why should I start doing simulations?
Well, I think, yeah, I mean, that's a great question because it might look like a daunting thing for a lot of folks to enter into. I guess that what I'd tell them is that they would do it to get operational certainty. When there's operational
Hmm.
uncertainty and the actual system is a battleground for set points and what this shift runs these set points, that shift runs another, um, that it's to drive operational certainty and even I think it's possible to see these systems and to feel the risks and I think that there's little certainty about what to work on next and what will really give me the biggest bang. There's robotics all over the place. People can use robots, to help their stretch wrappers out and so on. Um but one of the problems really in the industry is there's very little analysts in the manufacturing plant itself. There's so that's in a lot of the smarts, a lot of the smart folks who've been there a while are retiring. 30 years ago, 40 years ago, people operating an oven, baking a cookie, there was a certain pride of craftsmanship there, and I think that's largely gone. I mean, I think how to transfer that knowledge. We do have the opportunity, I think, to transfer that knowledge through systems that can help operators, give them guidance on the line in real time, etc. So think it's
Okay,
possible.
great. Well, thanks again.
It's been a pleasure.
Yeah, it's been an absolute pleasure. So with that, I want to thank our audience too, and we'll see you next time.
Okie dokie. Bye bye.